Okay, so we'll continue with NHR-Container project overview. Here are the partners who are involved in the NHR-Container project. We are 6. The project is in 2 phases. This year it ends in December, and next year it starts, and we will continue work on containers in HPC. Objectives are to implement solutions for running performance-oriented software in containers and using container services in HPC and providing cloud-like resources on HPC systems using containers. These are objectives for the next year project. So within the project, we had surveys. We have conducted a survey among 9 NHR HPC centers. The questions were divided into 2 categories or groups. First category is container platforms, and the second group is container management solutions. And I will give highlights on the following slides. Surveys about the container platform or runtimes. On this page, I show you the platforms used for users. So it means that users can run their containers or containers in general using these platforms on HPC systems. In production, all centers are using currently Singularity, and En route and Podman is one out of 9 centers are using to provide container platforms. And in plant, there is as well En route and also Charlie Cloud to in addition to Singularity to provide the container platform. For admins, it's another story. For administration purposes, to run services in containers and maybe something else in production, most centers use Docker, which is quite logical, since most of the services existing currently provided as Docker services. And second place goes to Singularity, because Singularity can run Docker images. And we also have NSpawn and Podman. And in plant, there's also Podman and Docker. And I think if anyone have questions so far, you can interrupt. We have time, so if you want, you can ask questions via voice. Okay. I will continue with container platforms, where people get their containers or the sources for containers. And in this graph, you see the division between users and admins as well, for user containers and service containers, which are hosted by administration, by admins. You can see that all the centers, they mainly provide self-built containers, or they run self-built containers for users. And what is more interesting probably for the admins, of course, it makes sense that you build yourself the systems that you want to run. So that's quite also logical. With respect to Docker Hub or similar, Repositories, also logical that for user part, this is main source for containers. Also for Singularity, because Singularity can run Docker files or Docker images, sorry. And therefore, all centers provide this option. And only 2 centers out of 9, they use Docker Hub for admin services. And there's also option of provided or the containers that are provided by providers or built by providers, by hardware providers or by software providers. And in this case, of course, it makes sense that these containers might not be available for building, so the code might not be available, or they are not available in the repositories like Docker Hub. And only 3 centers, they have their own repositories. Okay. There were also questions why to use containers. We had some options here that we predefined and some additional options that you see in the end. Those are commented by the centers additionally. So why to use containers? All centers said that users want to run containers from various sources, which makes a lot of sense since nowadays a lot of software is provided by within containers, and it's much easier to deploy when you have container and you can run it. Most of centers says that users want to run their containers on other HPCs, which also makes sense because it makes the code portable. User can build software easily by themselves, which is also true for containers. Admins need to maintain less software. It is also one of the main points why to use containers, that admins don't have to provide all the software that users need, especially complicated software with a lot of dependencies. And 6 out of 9 says that containers could be easily stored to reproduce the computations, etc. So for reproducibility, containers are also a good idea to have when you constantly updating software or the environment. Then you have basically one file where you have everything included. And additionally, complex software with non-HPC software stack, which was also one point why to use containers, that you don't need to build non-HPC software and the software that might not be interesting for all the users, and software with partially incompatible dependencies. So this were the reasons why to use containers. And there was also questions why to use particular container platform, and the reasons why to choose particular container platform various. We see here the list of various reasons. First is activity and the community of the platform. Then comes usage in other HPC centers, runs without a daemon. Security, of course, some containers, especially those who need some privileges, has some security risks involved with them. Also, Singularity, it has, for example, SUID bit on the binary itself, and therefore it might impose a security risk. Another reason is GPU compatibility. Performance-oriented containers also make sense to use them, as they don't use much resources themselves just to manage containers, and also support of Docker images, because it's kind of became a standard of writing the descriptions or building the containers. So support of Docker images, I find that it's quite important. So platforms in production. There is no single solution used widely. In container management, it makes sense that not a lot of centers are using it. And that was also the outcome of the survey, because not all services are running in containers on HPC centers. There are a couple of solutions that also get installed by the HPC providers, by the companies who deliver the HPC centers. They some of them have already the solutions which involve the containers heavily, and therefore they are being used very often. But in other cases, it's not very often that container services are running in HPC centers. And when they do that, they usually use Slurm plus fixes to manage the containers within the user jobs, for example. It's a plugin of Slurm, and we will also discuss it in the end within the Slurm talk. Then there's a Docker Swarm mode and systemd mechanisms, or systemd plus pacemaker within the container. So it was about the survey. In this slide, I want to show the general strategy for the project in 2022. Here on this figure, in this figure, you can see the main components of the project that we want to develop and to look into. On the top, there's a container management, and we have the user services, or the components that involve user environment and users. These are in green, and administration part or admin part is in blue. For example, in user containers component, we will investigate in the runtimes that users can run their containers with, as well as performance issues, how to run them in such a way that they perform as native programs compiled within the HPC systems, and as well as best practices. It will come as documentation on how to build or compile your software within the container or as a container image. We have on the left the opposite things. It is hosted services. Those services are provided for users as container services. For example, Jupyter Hub, which runs in the containers. In them, users cannot run the containers themselves, but they can use the environment that is provided within the container, and which is run by admins. And there we will, of course, talk about the container runtimes, which is needed for user containers, and use cases with examples on how to deploy these hosted services by yourself in your HPC centers. We'll provide the container images as well as documentation how to host the services by yourself. And we have HPC as a service. This component involves the running containers within some augmented resources, parts of cloud-based systems, for instance, or all the resources that not currently available for users, but extended on demand. So a good example would be cloud-based resources. Another component is the repository, where we will host all the containers which are involved, and might also host other user containers where users can share them. Of course, it's in discussion still, because there are a lot of repositories, and it might not make sense to build another one for user containers, but it will make sense to at least to host some of images on our repositories. And security. Security component will be about security within the containers, and especially security in user containers, and implications of using the particular runtimes securely on HPC. And in the bottom, you see the monitoring. It's explicitly monitoring focused on only the containers or container runtimes and user containers themselves. So this is our current strategy. And now you can ask any questions you have or write them down. You can ask, of course, questions regarding the presentation or workshop itself. You are very welcome to do it.